Electricity is a form of energy resulting from the existence of charged particles, such as electrons or protons, either statically as an accumulation of charge or dynamically as a current. In simpler terms, electricity is the flow of electric charges. It is a secondary energy source, meaning that it is converted from another primary source of energy, such as coal, natural gas, oil, nuclear or renewable sources like sunlight, wind, or hydropower. In the study of electricity, atoms play an important role in conducting or resisting the flow of electric charge. An atom is the smallest unit of an element. It consists of three primary components. These constituents are arranged in a specific structure, resembling a miniature solar system. At the core of an atom are protons, which are positively charged particles, and neutrons, neutral particles. They reside tightly bound together. Orbiting around the nucleus are electrons, negatively charged particles, occupying distinct energy levels or orbital shells. The distribution of these charged particles within the atom determines its electrical properties. In a neutral condition, the number of protons is equal to the number of electrons. During this state, the energy level of the atom is at its lowest. However, the energy level of an atom can be changed when it gains or loses electrons. When this happens, it becomes electrically charged. If an atom gains electrons, it becomes negatively charged because the number of negatively charged electrons exceeds the number of positively charged protons. Conversely, if an atom loses electrons, it becomes positively charged because the number of protons becomes more than the remaining electrons. Each element on the periodic table is distinguished by its unique number of protons, known as the atomic number. For instance, hydrogen, the simplest atom, has 1 proton, while carbon has 6. Each orbital shell has a specific number of electrons it can hold. The first shell, closest to the nucleus, has the lowest energy level and can accommodate a maximum of 2 electrons. The second shell can hold 8, then 18, 32, and so on. An electric circuit is the backbone of modern technology, powering everything from household appliances to advanced electronic devices. An electric circuit is a closed loop through which electric current can flow. It consists of several components working together to facilitate the movement of electric charge. Some of the most common components of an electric circuit is the power source, conductors, the load, resistors, capacitors, and the switch. When a circuit is closed, that is, when all components are connected in a complete loop, the power source creates an electric field that exerts a force on the electrons within the conductors. The wires or conductors serve as a channel for electrons to move from the negative terminal of the power source to the positive terminal, completing a circuit loop. This creates a flow of electrons, known as electric current, which travels through the circuit. At a fundamental level, conductors are materials that allow the flow of electrical current. Insulators are materials that act as barriers, preventing the flow of current. As electrons move through the circuit, they encounter various components such as switches, resistors, and other devices. These components may modify the characteristics of the electric current, such as its voltage, current intensity, or direction. Ultimately, the electrons return to the power source, completing the circuit loop. Take note, connecting the two power terminals, positive and negative, directly to each other is highly dangerous and can result in severe hazards. In such situation, there is no device such as a bulb or any device to absorb the flowing current, creating a significant accumulation of electric current. This can generate significant heat, potentially leading to a fire hazard if not promptly addressed. Now, to quantify and manage electricity, various units of measurement are employed. The most common units are volts, ampere, ohms, watt and coulomb. Volts represent the force that pushes electrical charges through a circuit or conductor, such as a wire. Think of volts as the pressure in a water pipe. The higher the voltage, the more force there is to push electrons along the electrical circuit. It was named after an Italian physicist, Alessandro Volta. Amperes, or simply amps, quantify the flow of electric current. Amps indicate the quantity of electrons passing through a circuit per unit of time. A higher amperage means more electrons are flowing, creating a stronger current. Electrical devices are designed to operate with a specific amperage, and exceeding this limit can lead to damage or even electrical fires. It was named after French physicist André-Marie Ampère. The ohm is the unit of electrical resistance, denoted by the Greek letter omega. 1 ohm is the resistance that allows a current of 1 ampere to flow with a voltage of 1 volt. It was named after German physicist Georg Simon Ohm. The watt is the unit of electrical power, measuring the rate at which energy is consumed or produced. Watt is equivalent to 1 joule of energy per second. Common household appliances are often labeled with their power consumption in watts. It was named after a Scottish engineer, James Watt. The coulomb is the unit of electric charge, named after French physicist Charles-Augustin de Coulomb. 1 coulomb is defined as the amount of charge transported by a current of 1 ampere in 1 second. Electricity can be generated using various sources, each with its own set of advantages and challenges. However, as the globe turns towards sustainable practices, renewable energy sources are gaining prominence. Solar plants generate electricity without depleting finite resources or causing harmful emissions. Wind turbines capture kinetic energy from the wind, turning it into mechanical energy that is then converted into electricity through generators.